I'm going to look at some example problems here of solving quadratic equations using this thing called the quadratic formula. So remember, quadratic equations, I have to have my variable squared. That makes it a quadratic equation when that's my highest power of my variable. The quadratic formula depends on having my equation written so that all the terms are on one side set equal to 0 and everything's cleaned up like this. When it's set up this way, I can look at the coefficients. Now remember, in front of the y squared there's really a 1 here. So for the quadratic formula we identify a, b, and c. So my a here would equal 1. My b would be negative 2. The sign has to go along with that. And my c would be negative 8. Right? So I just read those coefficients off. It's always a in front of my squared term, b in front of my linear term, and then my constant c. And then, of course, to use the quadratic formula, you need to remember what the quadratic formula is. So we've got x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. I always say it to myself in my head the same way every time I write it down to help get it correct. The next part then is I just plug in these three values for a, b, and c anywhere that they appear over here. The one place people sometimes make mistakes using the quadratic formula is getting some sign errors, especially inside the square root here. One way to avoid that is to rewrite this formula, but instead of every a, b, or c, write a set of parentheses. So I got my fraction bar, negative b, so parentheses, plus or minus the square root b squared minus 4 times a times c all over 2a. See what I've done? Every value a, b, or c just got replaced with a set of parentheses, and now I just fill in my values. So instead of b, I put negative 2. Instead of a, I put 1. And instead of c, I put negative 8. All right, so now I just start simplifying. So here, the opposite of negative 2. Well, that just becomes positive 2. Negative 2 squared. Negative 2 times negative 2 is positive 4. This next part here, there's two ways of thinking about this. We can either think of this minus sign here as a subtraction or as a negative. I myself like thinking of it as a negative, so I think this is negative 4 times positive 1, so that's negative 4 times negative 8 is positive 32, so this becomes plus 32. And then 2 times 1 is 2. The other way to think about it is to forget about this minus at first. Just say 4 times 1 is positive 4. Positive 4 times negative 8 is negative 32, but then you get minus a negative. Minus a negative 32 turns into plus 32. So we get the same answer either way. However you think about it best is how you're going to want to do it. So 2 plus or minus the square root of 36 all over 2. A couple things here. Other mistakes that people make, they try to start canceling, doing weird canceling. I cannot cancel out these 2's. I certainly can't cancel anything with this 36 with this 2, because I can't cancel something inside a radical with something outside a radical. The other part is I can only cancel something out if it's a common factor. It has to be a common factor of the whole numerator and the whole denominator. Now 2 is definitely a factor of the denominator, it's just 2 times 1. But this 2 is not a factor of the whole numerator. A factor is part of a multiplication problem. And this now has addition and subtraction in between. So I can't cancel out a 2 here. In this particular problem, I can take the square root of 36. The square root of 36, of course, is just 6. And in this case, then, I can actually divide this into two parts now. I would get 2 plus 6 over 2. And I get 2 minus 6 over 2. So 2 plus 6 would be 8 over 2, which is a solution of x equals 4. 2 minus 6 is negative 4. Negative 4 over 2 is negative 2. And those are my two solutions. Now, in this particular case, just to show that this really works, oh, I solved this all with x. It was supposed to be y. That's easy. Y, 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 y. There, fixed. This particular problem, since I got these nice solutions, it turns out I could have factored this equation to solve it. This would have by far been the faster way of doing this. I need two numbers that multiply together to give me negative 8, so that means they have to have opposite signs. I think if I do minus 4 and plus 2, that works. So y minus 4 equals 0, y plus 2 equals 0. So I get y equals 4 and y equals negative 2. So these were my two solutions by factoring. Those are the same solutions I had here with the quadratic formula. Obviously, if you can factor an equation, that's the way you want to go. But the quadratic formula gives me the same answers. All right, let's do the second problem here. Okay, now this problem, my issue is it's not set up in this nice form. So I need to have everything set equal to 0. So this 4n I'm going to have to move, so I'm going to subtract 4n from both sides. So I'm going to get 0 equals 4n squared minus 4n minus 15. Now it doesn't matter what side the equation is on. I can look at this right here and figure out what my a is, what my b is, and what my c is. So I've got a is 4, b is negative 4, and c is negative 15. Notice the n doesn't become part of any of these a's, b's, or c's, right? The variable does not go in for the coefficients. Now I need to use the quadratic formula. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to replace every letter with a set of parentheses. That helps avoid sign errors. B squared minus 4ac all over 2a. And now I just plug in my values. B is negative 4. A is positive 4. Oops, what did I do down here? All right. A was positive 4, and C was negative 15. Okay. So, minus a negative turns into a positive. A negative squared is positive. Here, let's see. 4 times 4 times 15. Well, I know 4 times 15 is 60, so that would be negative 60 times a negative 4 is positive 240. 2 times 4 is 8. So I get 4 plus or minus the square root of 256 all over 8. Turns out the square root of 256 is a nice number. You can use your calculator to test that. It turns out to be 16. So then I get two solutions here. X equals 4 plus 16 over 8, or 4 minus 16 over 8. So that's 20 over 8. I can divide top and bottom here by 4. So one of my solutions would be 5/2. 4 minus 16 is negative 12. Again, I can divide, it looks like, by 4. So it's going to be negative 3/2. Oh, I did the same thing here. I did x, it was supposed to be n, right? So, I don't know, I'm having variable issues here. So all those should be n's, not x. All right. So those first two examples, those problems came out nicely, which means they could have been solved by factoring. This problem, that's not the case. We wouldn't be able to solve this one by factoring. When we look at this, we see the a, remember, is whatever is in front of the x squared. If there's nothing in front, that's really a 1. So a here is 1, b is negative 3, and c is negative 11. So my solution, the quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. I replace with parentheses. And then I just plug in. So b is negative 3, a is 1, and c is negative 11. So the opposite of a negative is a positive. A negative squared is a positive. Here I get negative 4 times 1. That's negative 4 times negative 11 is positive 44. And so I get 3 plus or minus the square root of 53 all over 2. So my solutions here, I've got 3 plus the square root of 53 all over 2, and I've got 3 minus the square root of 53 all over 2. All right, so this problem, again, quadratic equation, I've got the y squared. I have to remember it's y, not x. I could say a is a half, b is negative 4, and c is 3. But then I have to plug in a fraction. Now, this is an equation, so since it's got an equal sign, it's an equation to begin with, I just have to maintain the balance on both sides. So what's really going to help me here is just to take this equation and multiply both sides of the equation by 2. So then that has to get distributed to every term in the equation. So I've got 3 terms on the left, and I've got the 1 term on the right. I'm just going to multiply everything by 2. So 2 times a half, that cancels out. I'm left with just y squared, and then I get minus 8y plus 6 equals 0. And now I get better values for a, b, and c. I get a equals 1, b equals negative 8, and c equals 6. So x equals, y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. 2a. I'm going to replace every letter with a set of parentheses. I'm going to fill in b is negative 8, a is 1, and c is 6. And then I just simplify. Minus a negative turns into a plus. Negative squared is positive. Four times 1 times 6 gives me 24. So 64 minus 24 gives me 40. Couple things. first of all, I can't cancel anything inside a root with anything outside a root, so I can't cancel the 2 and the 40. Second, you might say, oh, 2 goes into 8. Yes, but 2 is not a factor of the whole numerator. 2 is just a factor of the 8. This plus or minus means 2 would also have to be a factor here, but like I said, that 40 is inside the square root. In this problem, though, the square root of 40 can be simplified. I can find a perfect square that goes into 40. And so I have to do that here. I can say that's the square root of 4 times the square root of 10 because I know what the square root of 4 is. Now, there are a couple ways you can proceed here with simplifying this problem. One way is to look at this numerator and say, is there anything that goes into both of these terms? I don't really worry about the square root. I can't pull anything out of the square root. But is there anything that goes into 8 and 2? It's like, well, yeah, I've got a common factor of 2 there. Then I would play sort of what's missing. 2 times what gives me this 8? Well, it would have to be 2 times 4. And then 2 times what gives me this thing? Well, it's 2 times that square root. So I'd have plus or minus the square root of 10, and I've got the 2 in the bottom. And now that's a multiplication there. These are common factors that I can cancel out. And so I would get y equals just 4 plus or minus the square root of 10, well, over 1. So 4 plus or minus the square root of 10. And again, then those are really two solutions, 4 plus the square root of 10 and 4 minus the square root of 10. Another way we can do this, if we sort of think about what was happening there, we're saying, well, this 2 is a common factor of the numerator. Basically, I can cancel this 2 with the numerator as long as I cancel all the terms. 2 goes into 8 4 times, 2 goes into 2 once. So I get the same solution. Either way is a perfectly valid way of thinking about this. You can either factor it out in the top and then cancel, or cancel as long as you cancel with each term. What I can't do is go back here to this step. I can't cancel like 2 and 8 there. That doesn't work. So don't do that. Don't get cancel happy on me. Okay, we have to do like I've done here at the end to get the valid solution. Okay, this one's pretty straightforward, right? It's already in the right form. It's pretty easy to say C A is 1, B is 2, C is 2. So I just write down the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to use parentheses. And I'm going to plug in b equals 2, a equals 1, and c equals 2. So negative 2 plus or minus the square root of 2 squared is 4. This becomes minus 8, right? Negative 4 times 1 is negative 4. Negative 4 times positive 2 is negative 8. And here we have something different sort of happen. We've talked about this already, of course, in other situations, but here then I end up with a square root of a negative. So that's all right, but it means I'm going to get an I involved. The square root of a negative is I. And of course the square root of 4 is just 2. And we have the same issue here that we had in the last problem. I can either factor out the 2 in the top, right? 2 times negative 1 is negative 2. 2 times I is the 2i. And then cancel to get x equals negative 1 plus or minus I. So my solutions then, we get negative 1 plus I and negative 1 minus I. Or I could come back here and I could say 2 goes into itself once, 2 goes into itself once, 2 goes into itself once. I have to cancel every term. So I still get the negative 1 plus or minus I. All right, one more example. This problem is a little messy. It doesn't look like these quadratic equations look. So I'm not sure, is this even a quadratic equation? Well, I need to clean this up and get it in a nice form. I need to get rid of these parentheses, so we're going to use FOIL. First, x times x squared. Outer, x times negative 4 is negative 4x. Inner, positive 6 times x is plus 6x. Last, positive 6 times negative 4 is negative 24. Now I see, okay, this is a quadratic equation. I've got an x squared. I'm going to clean up these terms. I can put those together, but then I want to get it equal to 0. So I'm going to put these terms together, and I'm going to get rid of this 32. I'm going to add 32 to both sides. So I get x squared, negative 4 plus 6, positive 2x. Negative 24 plus 32 gives me plus 8 equals 0. So I've got a equals 1, b equals 2, and c equals 8. No signs there at all. That's sort of nice. So I write down minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, since I don't have any negatives for a, b, and c, maybe I'm not going to bother with the parentheses. If you do the parentheses or not, that's really your decision. Okay? Just don't leave them out if you find yourself making mistakes. So 2 squared, a is 1, c is 8, 2 times a, 2 times 1. All right? So again, I'm just taking these values and I'm plugging them in for a, b, and c. So 2 squared is 4. Looks like here I get 4 minus 32 all over 2. So that gives me negative 28. Remember, I can't cancel here because it has to be part of the whole numerator. I've got a negative inside. That means I get an I. And this problem has it all. 28, I don't know what the square root of 28 is, but I do know something I can take the square root of that divides into 28. Right? 4 goes in there. So I've got the square root of 4 and the square root of 7. So square root of 4 is 2. I've got the I still, and I've got that square root of 7. And now it's up to you. You can either factor that out, or I can say here 2 goes into itself once, 2 goes into itself once, 2 goes into itself once. So I get x equals negative 1 plus or minus 1i square root of 7 all over 1. Or that's really just negative 1 plus or minus I square root of 7. Remember here, I write the I in front of the square root of 7 instead of behind it, just so it's clear that that I is not part of the square root.